Hello, everyone. Thanks for standing by. I'm Amy Hyde, editor of Pumps and Systems Media. Thank you for joining us and welcome to Fast and Effective Ways to Remove Heat from Your Control Cabinet, presented by Advanced Cooling Technologies. As a reminder, this event is being recorded and will be archived on pumpsandsystems.com/webinars. To get a certificate of participation for attending this webinar, please email me at ahyde@cahabamedia.com. I'll also place my email in the chat feature. It's my pleasure to introduce our speakers, Devin Pellicone and Mark Stevens. Devin is the manager of product development for Advanced Cooling Technologies. He has over 10 years of experience designing and building both passive and active two-phase cooling systems for a wide range of applications. Specifically, he has led two-phase cooling programs ranging in power from 100 watts to 100 kilowatts for industries like high-performance computing and power electronics cooling. Devin has 2 patents pending that are related to two-phase cooling products and has authored or co-authored numerous conference and journal papers on the topic. He has a Bachelor of Science in Mechanical Engineering from Temple University and a Master of Science in Mechanical Engineering from Villanova University. Mark Stevens is the market specialist for Advanced Cooling Technologies. Mark brings over 25 years of product management, product development, and field application experience in the area of industrial controls and automation systems. He has been with ACT for nearly 10 years and was instrumental in the launch of the HVAC energy recovery product in 2012 and the sealed enclosure cooling product line in 2016. Mark supports both inside and outside sales globally as the market specialist. He uses his technical ability to provide management support and in some cases, field install support. In addition to rep support, Mark calls on the mechanical engineering community to present the application benefits of utilizing passive heat pipe energy recovery systems. At this time, it is our pleasure to begin the webinar. Please stay tuned after the presentation for the interactive Q&A session. Throughout the presentation, we welcome you to send your questions for our speaker, and we'll get to as many of them as possible. Now let's get things started.
Yes, thank you very much, and welcome everyone. This is Mark Stevens, also joined by Devin, as you heard. We're going to go through the system today and hopefully give you some good tips on how to cool industrial control cabinets and commercial cabinets. So, what we'd like to talk about today is calculating the design and heat loads and component waste heat, how solar loading is affecting your cabinets, and then the convection effects of heat inside of your cabinet as they would require more or less cooling. We're also going to take a look at the best enclosure coolers for your application and understanding the seal ratings and environmental ratings. And then what makes the sealed enclosure cooling different than a fan filter system. And then we'll have some installation and operational considerations. And how do you know when you might need a custom design, which we've done for a number of customers as well. So one of the key things that you'll keep hear us mentioning today is the term sealed enclosure cooling. And when we say sealed enclosure cooling, we really mean that whatever is occurring on the outside of the cabinet doesn't get into the inside of your cabinet. And so what we find is some of the typical industries that we serve are industrial process control. We're in the petrochemical area, telecommunications, food process, military, and telecommunications, electronics type enclosures. Also, the environmental ratings. We have units that address NEMA 12, NEMA 4, 3R, and 4X. And what we've put together is the rough equivalents in IP because there isn't any real direct rating. So we've done our best estimate on what a NEMA 12 is for an IP rating, which is 52. And then if we talk about our 4X, it's probably pretty close to a 65 to 66. So that's our best approach when trying to take a look at these products. We also did some special testing on our HSC lines, our heat sink coolers. We had them tested to the UL50E washdown spray down test. So a lot of times as a company, you can self-certify your NEMA 4 or 4X rating. And we actually took the extra step and had UL do the testing. So we've qualified for the 50E rating. A lot of times when you're out and about taking a look at cabinets in the field, Probably one of the biggest mistakes that you'll see in an industrial plant is doors open to try to cool them with a fan. This is not really good for the equipment, and it's quite dangerous because of arc flash and other things you could run into. And so by keeping the doors open, you're really not serving the electronics well or any of the controls well. And what will typically happen over time is you'll have a cabinet that looks pretty ugly and awful, and you could get bridging and other occurrences inside of the cabinet that could cause damage, along with things getting insulated and heat developing because you have dust and mold and all kinds of other things growing in there. So to take a look at what we're doing here with our approach is that a very common cabinet cooling approach for above ambient type cooling, which means that the inside of the cabinet is hotter than the outside of the cabinet, is that people will use a fan cooler system where we're drawing outside air to the cabinet internally and then pumping that air through the cabinet and then out through the top or the sides. And so what really differentiates the whole approach that we're taking today is that we have a sealed type cooler system. So we're conducting through a center plate, and we'll show you a better picture of it in a few slides here. But the outside is being driven across some fins through a fan, and those fins are being cooled because they're tied to a conductance plate between the inner and outer cabinet, making a continuous seal. So for wash down, spray down, dust, or whatever the environment is, it's not getting into the cabinet. So as your cabinet is getting hotter and hotter, that heat is then circulated through another fan and some fins that are bonded together to the outer fins and fan. So all of that heat is then conducted and rejected to the external cabinet. And so depending upon the load of heat within your cabinet, the heat load, we'll either use a 1-fan system, a 2 or 3-fan system that you can see here for above ambient systems. So we have a pretty large family of products. In the above ambient area, we have what we call our heat sink coolers to the left. Those are the ones you see with the 1, 2, and 3 fans. And then we also have a range of heat pipe coolers that address the same types of applications, just different mounting features. They may react a little bit quicker, and the one can do up to about 1,600 watts of cooling. But that again means that the outside of the cabinet has to be colder than the inside of the cabinet. If you have the reverse, where the outside of the cabinet is hotter than the inside of the cabinet, we go with our below ambient coolers, which Devin is going to speak about at the end of the presentation, and that's our air conditioning line. So again, as I mentioned, the way our heat sink coolers are set up, you have the cool ambient outside air going in and circulating through some finned fans or some fins that are bonded to that center plate. And then the mirror image of that is on the inside of the cabinet. And there's a center gasket and a conductance plate that totally isolates the inside from the outside. So nothing gets in as far as contaminants. And then just to give you an idea of the specifications here, we have 3 product ranges in the heat sink cooler line. That's what the HSC stands for, heat sink cooler. And you see a conductance watts per degree C. So when you see a HSC 22, that means for every degree C, you get 22 watts of cooling. So we typically look at these with a 20-degree delta. That's the way the industry kind of segments these as far as ratings. So if you have a 20-degree difference between the inside to the outside of your cabinet, an HSC 22 cooler is capable of 440 watts of cooling. A quick way to look at that is if the differential is only 10 degrees, that same cooler is only capable of 220 degrees or half of the 440. So it's pretty easy to specify based on if you know what your internal heat loads are. And we have ways of calculating that coming up as well. And here are the 3 product ranges, the 22, the 45, and 68. So again, the 68, if you multiply that by 22, you should get 1360 as far as the watts. There you can see approximate sizes. The HSC 22 is about a 12 by 12 inch square with about 3.7 inches of depth inside the cabinet. So it doesn't really take up a lot of room inside the cabinet. So any obstructions, it probably won't really hit or get in the way of anything that's currently inside. And then as far as the current draw, these are very low current draw devices. And the fans have a life of over 100,000 hours of operating. So they have what we call an L10 rating. And even at the end of the 100,000 hours of operation, they're still capable of 90% or more of their original fan capacity. So very robust type system. And then today too, as you're watching this, we do have a promotional code that gives you 10% off on any of the items that you see through our online store. And then as we go through this, we're going to show you what the selection tool does as far as the components waste heat. Devin will talk a little bit about solar loading and the convection effects of solar loading. And probably your best defense against solar loading is insulated cabinets. So we'll go through and talk about those as we get through the slide pack. And then we do have the sealed enclosure cooling solution website. It's really great. It has a lot of case studies, a lot of deep information on the systems. Also has DXF cutout drawings, everything you need to install the products. And then in a little while, Devin's going to go over the selection tool and how easy it is to come up with a selection and make a pick for the correct product for your application. And that also will include solar loading and where to mount the product on your cabinet and how that affects the rating. So one of the nice things is that if you have some very caustic or hazardous environment, not hazardous environments, but caustic environments where there's acids, salt sprays, wash down, spray down chemicals and food process, we have a NEMA 4X line, and they're all stainless steel. The fans are potted. And again, whatever's happening on the outside of the cabinet's not getting into the interior. And if you see around the rims of those products, it's a black center plate. And that black center plate, the reason it's black, it's coated with something called electrofin coating. And the cooling fins that are on the sides there are also coated. And so that electrofin coating gives you that security against any corrosive atmospheric environments or chemical sprays. So let's talk about a couple of applications as we take a look at the market. One of the interesting things is that some of our customers have gone the extra mile and actually put together their own rooftop test. And in this particular application, this integrator who is going to later then apply this product through pump station panels, which we'll show you in the preceding slides, the following slides, is that you'll see the fan mounted, and he tested these for about 3 months in a nice hot Georgia sun. And our product had a very good rating, even with a gray steel case. So that's the HSC mounted, HSC 22 mounted on the side. So what these were used for then finally throughout one of the large counties around surrounding Atlanta, these were used on a booster pump station. And there's probably going to be about 70 of these by the time the project is finished. The particular version that you see here in the picture is an HSC 45, but they ended up going with HSC 22s, which is a single fan unit. One of the things that we did custom for this customer is that we painted it to pad mount green. So that was a custom color that they wanted. So anything that was external matched nicely. And then on the inside, we kept the stainless steel, and that cooled some drive and pump motors that were inside of the cabinets. Another application was for wastewater. This waste scale system was sending back information via probably some type of Ethernet, and then wireless Ethernet, and the cabinet was getting too hot in the summertime. So just by simply adding one of our fan coolers on the outside gave enough boost to keep that system running properly throughout the hot summer months. This was in Denver, Colorado. These units were cooling a whole series of drives. And this was for a gas pump station. So a lot of times you may think that you need to throw air conditioners in to cool things, but just the fact that you're moving air and conducting heat through those center plates and cooling off the interior temperatures of those cabinets gives you enough temperature drop that things operate reliably. And also the fan coolers do have less things that can go wrong because you're not running a vapor compression cycle and some other things. So your mean time before failure is probably a bit higher than something that has a vapor compression cycle. Not to say that the air conditioner isn't a good solution. And so there you can see this mounted on the left-hand side of that pump station panel. There's one of our team members out there, very proud of the install. So we have the two families again, the above ambient heat exchangers and below ambient. And so what we'll move into now, and I'll let Devin take over, and he's going to talk about our AC units.
Thanks, Mark. We do have a entire suite of air conditioning enclosure coolers. They offer the same IP55 or NEMA 4 equivalent seal rating to the system. So they still maintain that sealed enclosure cooler concept that Mark has been discussing. The difference here is that these allow the cabinet to operate at a temperature that's below the outside air, much like a window air conditioner that would be in your house. This is very similar, except it seals to the side of your cabinet. They come in 4 sizes that are at least in stock at ACT. We have 2 DC powered versions. The DC powered units are a 48-volt DC system. They come in 3,000 watts of cooling capacity and 1,000 watts of cooling capacity. That wattage is measured at a delta T of 0 degrees between the outside and the inside. So it's a maximum cooling capacity. If you go on our website and look up the specification sheets for these units, you'll find that they have performance curves as a function of inside and outside temperature. So you can find your operating conditions that you want, follow the curves over, and figure out how much cooling capacity each one of these units can do. Alternatively, we'll show you in a minute our selection tool that'll do that hard work for you. The AC units on the right are a 220 volt AC system. They come in 2,000 watts and 5,000 watts, again, of cooling capacity at a 0 degree delta between inside and outside temperature. And all of these units are what we would consider in stock and available for purchase on our website. There are custom options, again, for this product line where we can do in between power capacities, different configurations of the enclosure, and add options like heating to the system. Those units are not in stock. They tend to have longer lead times and may be different pricing structure, but those options are available. And again, for this product line today, we're offering 10% off any of these vapor compression cooling VCC enclosure coolers on our website using the promo code VCC promo 10 on our website. These systems have smart controllers on them. Unlike the above ambient coolers that Mark was mentioning, these are actively controlled units. So they have temperature controllers where you can set the set point for your operating conditions. The display on the front here also comes with a number of warning lights, status bars, tells you what the unit is doing. And we also have remote communication capability. You can see that green plug being shown there. These units have the ability to communicate through RS-485 communication, and there's also a Modbus table or protocol that can be used to communicate with the units and operate them remotely. And all of that's available in our operating manual, again, that can be found on the website. This is a schematic showing you how these enclosure coolers mount to the system. Most of our customers like to mount the vapor compression coolers to the door of the cabinet. They tend to be relatively large units, but as far as taking up space inside the cabinet, what you can see from the side view is that the majority of the system is positioned outside the unit, and only a small portion of it, less than a quarter of the thickness of the cooler, actually sticks inside the cabinet. What we're showing in this picture here is actually a insulated cabinet, like Mark was mentioning, which is particularly important for the sub-ambient coolers to optimize their performance. And you can see the cooler barely sticks in past the insulation that's inside this cabinet. The outside portion of the unit has provisions for a drain port, so you can collect the condensate. It'll collect in the bottom of the unit. That condensate port you can attach a hose to and route that condensate in any location that's most convenient to your cabinet. There is some options for being able to duct the outside air to the unit, or also remotely mount the vapor compression cooler and duct the cold air into your cabinet. That's a rare option that some of our customers like to use, but it's available. So you can sort of use this, this unit as a remote cooling option and just provide ducting to your cabinet if you have no room inside the cabinet at all. So now we're going to walk you through how our selection tool works on our website. So we'll just click on this link here, which will bring up our online tool. And when you're on the website, you can see there's a number of options for inputting your information. First, you start with what type of units you'd like to work in, degrees Fahrenheit, Celsius, or inches or millimeters. And we request the dimensions of the cabinet. This helps us to identify any of the heat losses that will naturally occur off of the cabinet, as well as identify which units will fit best inside of your system. So you provide the cabinet dimensions on the left here and whatever units you selected. And then on the right, we're asking some more information about the cabinet specifically. So it gives you a number of checkbox options for where you would like to mount your cooler on the top of the cabinet, which would be obviously the top, then left, right sides, front and back are all the available options here. And you typically just want to select one or maybe two of these options here to make sure you get relevant results in the selection. The surface finish of the cabinet is important for how much of the heat will be absorbed from the sun. So this is a solar radiation input for our model. So if you have a particularly dark colored cabinet, it will absorb more sunlight sitting out in the open sun as opposed to a white or lighter colored cabinet. So making sure that you select the appropriate color for the cabinet you have will give you the most accurate results. And then some cabinets are insulated or not. That's an input to our model. So make sure that you select that appropriately. And if you ever have questions about what any of these boxes mean, there's a question mark symbol on the side here, and it tells you exactly what your input may mean to the cabinet. So if you select yes, we calculate an R5 value for the cabinet, some thickness, just to give you an idea of what kind of assumptions we're making when running through this selection. Down at the bottom here on the left is where you put in what temperature you're trying to achieve on the inside of the cabinet. This is the maximum allowable temperature you'd allow your air in the cabinet to be. And then the maximum temperature you expect the outside conditions to be. So this is what we would consider the ambient condition. And then importantly, we're calling it waste heat here. This is the amount of thermal watts you believe your system is dissipating. It's not the electrical capacity of your cabinet. It's just the heat that's being generated on the inside. Most times you can calculate this number by adding up all of the losses from the modules or devices that you have populated in the cabinet. That heat value is what gets input here so that we know how much heat we need to be able to dissipate from your cabinet. The last selection that you need to make here is what surfaces may be exposed to sun and airflow. There are some applications that are completely indoor, in which case you'll basically select none of the solar. And the airflow is what faces of the cabinet are exposed to free-flowing air. If you have 3 cabinets stacked up next to each other, that middle cabinet will only have free surfaces on the front, maybe the back and the top. And so you want to make sure that you select those free surfaces applicably. All of this information is important because the natural losses off the cabinet tend to be pretty significant in most applications. And if you don't account for those, you wind up oversizing the cooler for your system, which may not be an effective solution for you. Once you click calculate at the bottom, it'll show you a series of selections here, ranging from the lowest cost option. It'll also let you know if we think that multiple coolers may be best for your unit, and if a sub-ambient or an above ambient cooler fits your application best. And then you'll have the opportunity to purchase that unit directly from our website here with 2 more clicks, and that information will come to us and your unit will arrive in the mail.
And at this point, we're going to do just a quick polling question. So I'll turn it over to our moderator.
All right, everybody, the poll should be showing up, so just take a few seconds to answer that.
Okay, looks like we're settling out.
All right. So there are the results of the poll. Looks about 63% said yes and 37% said no.
Terrific. And yes, thank you for that poll. Just trying to get us back into the presentation.
And just a reminder, please feel free to put any questions in the chat or the Q&A feature, and we'll get those answered at the end.
Okay. All right, so we're just going to finish up on the section here. It says some of the things that we're looking at is, and how do we know when you need a custom design? We do create custom type enclosure coolers. We've done some liquid to liquid coolers. We've done custom grading for high arc type conditions, things that are mounted on power poles. They needed to be redesigned so that there were no sharp edges or fan grates. Everything had to be smooth for arc. Custom painting, which you saw. So those are some of the things that we can take a look at for custom. A lot of times too, sometimes you want to fully flush mount something either on the inside or outside of a cabinet. We've created special mounting plates that allow for that. Does your application require higher heat transfers or cooling performance than our standard offering? Well, we can also work with you on a custom design that could have higher cooling capacities. We have some technologies here at ACT that can do up to 90 kilowatts of cooling. So we're your team for that if you're looking for that level of cooling. And also we have considered applications for Class 1 Div 2 installation as well. And then installation and operational considerations. Again, when you're taking a look at applying this product, which ones do you pick? Is it an above ambient or sub-ambient? So you always have to consider, is the temperature inside of the cabinet hotter than the outside of the cabinet? If it's hotter and on the inside of the cabinet, you can get away with probably using a above ambient cooler. Again, as Devin was talking about, in the air-conditioned products, the outside of the cabinet is going to be hotter than the inside of the cabinet, so you're going to have to cool it with an air conditioner. And then is the enclosure installation located indoors or out? That may affect the NEMA rating of the product that you pick. And then are there corrosive or contaminants? Well, then you'd need to pick like a NEMA 4X product. And is the enclosure installation exposed to sunlight? And as Devin showed in the one picture, and as you go through different calculations out there, insulation is your biggest friend to help you with solar loading. Just a mere half inch or a quarter inch of insulation makes a huge difference in the amount of wattage that you would require for cooling and installation. Also, at our website, we have a whole series of installation guide videos, application videos. Devin's done a couple others on data center cooling. So just take a pop on our website and take a look and see what's available there. If you don't like to read, you can watch videos too. So there's a lot of information content, a lot of useful content on our website for enclosure coolers. And then, as we mentioned, we've got a great website and then a whole series of print brochures and application guides that you can print out, as well as the manual on the AC units and a really good sealed enclosure cooling technical guide brochure too as well. And if you're looking for cutouts, we have DXF files that you can print out, large cutouts or step files that make it easy to cut out the hole in your panel to mount the product. And then there are quick downloads on any of these. So with that, we're going to get into the Q&A. We'll open it up for questions.
Okay, great. So the first question, I think you already answered this, but we have a question that says, is your cooling unit good for Class 1 Division 2 environments?
Yes, they are, except they are not currently rated for those types of installations. But depending upon if it's a purge cabinet or not, sometimes you can utilize our products in a purge cabinet environment. So that would give them that rating for that installation. But if you are interested in that, we'd really like to talk to you, depending upon the size of the opportunity and what class and what zone that you're in. And, is it class A, class B, or C location? So those things we'd be interested in chatting with you.
Okay. The next question we have is, are you using fluid through the fins to control the thermal temperature?
We are flowing air through the fins, but we're not actively controlling the fan speed on these systems. At least we're not controlling the fan speed on the above ambient coolers. So the HSC and the HPC coolers, the fans run flat out when you apply power to them. So they're not doing any active temperature control. For the subambient coolers, they do have fan speed control and compressor control to modulate a specific temperature within a band that we specify in the spec sheet for that specific unit. So those are active temperature control units. We also have a thermoelectric cooler, not shown here, that does something very similar, maybe even a little more precise than the vapor compression coolers.
Yeah, and also on the HSC, the heat sink coolers and the heat pipe coolers, some customers have put their own thermostats in, so they only run when the cabinets get to a certain amount of heat. So that's another thing that you could apply from an aftermarket product.
Okay. The next question is, how do the NEMA 4X fan cooling products hold up to H2S or sewer plant applications?
As I mentioned, the coating on these products is very good. The electrofin coating, we can provide you all of the spec sheets. There's ASTM applicable standards that coating is applied to, and it holds up very nicely to salt spray, hydrogen sulfide, ammonia fumes, and other things. And then the fans themselves are potted, so there's no issues with the hydrogen sulfide or other contaminants getting in to hurt the fans. And then the casings themselves are all 316 stainless, and the screws are stainless, and the gasket is a chemical rated gasket as well. So they're very robust in those types of environments.
Okay. The next question is, how much space from the ACT cooler do I need from components inside my cabinet?
That's a function of which unit you select. On our website, I think we showed a couple of tables in this presentation as well, but on our website, we show the both exterior and interior dimensions of every cooler. The HSC units and HPC units stick into the cabinet different amounts, and the vapor compression coolers probably stick into the cabinet the least amount, but are larger in overall cross-sectional area. So you'd have to go on the website or send us a specific inquiry, and we can provide that information. We have it available for all of our units.
Okay, great. The next question is, what do you think about compressed air tube coolers?
Oh, like the vortex coolers.
Mm-hmm.
Yeah, they require a lot of energy to run. You're always having to have a compressor, constantly supply the compressed air to them, and they're very noisy. So I think they're functionally fine. It's just application wise, I think our solution is a little bit more elegant and nicer to handle. So Devin, do you have anything to add?
Yeah, I think one of the biggest downsides to them is that not all applications have compressed air.
Yeah, that's true.
So if you have a cabinet, like a lot of the sewer and gas applications, oil, gas applications, wastewater applications are sitting out kind of in the middle of nowhere. Compressed air is not always available. And so that type of cooling solution has several limitations.
Yeah. Good technology, just may not be applied everywhere.
Sounds good. The next question is, have customers ever applied 2 heat exchanger units to meet the heat load?
Yeah, quite often actually, and our selection tool will tell you when that's necessary. If you have particular cabinet dimensions where one bigger cooler won't work, but two smaller coolers, maybe on different faces of your cabinet will work, our tool will recommend that for you. So we offer that to many customers, and it can be a solution for some customers that need redundancy or just need to trim the temperature in the cabinet at maximum extreme temperature days, but don't run the second cooler most of the time. There's a number of different scenarios where that may be applicable.
Okay. Another question is, what is the recommended temperature in enclosures and what international standards are referenced for the max recommended temperature?
Well, the max temperature for components is basically what the manufacturer states. Like most PLCs, you probably don't want to take over 90 degrees. I mean, they will operate up to 120 degrees Fahrenheit. A lot of drives, as you get hotter and hotter, they derate. So most industrial control systems can take about 120 degrees. So I don't know if there's any specific temperature standard that says a cabinet has to be a specific temperature. You really have to go by the manufacturer's component rating of what's being applied in the cabinet and then try to address it accordingly.
Okay. One more question. Are the ACT air conditioners wash down / spray down?
Yes, they are. They are the equivalent of NEMA 4 rated enclosures. And so they could be wash down, spray down. They're wash down, spray down tolerant, and so you can hose them down as needed.
Okay. Well, everybody, that'll do it for questions today, which brings our webinar to a close. We'd like to thank our sponsor, Advanced Cooling Technologies, for the great information they shared with us today. Of course, thank you to Devin and Mark, and thank you for your questions. Attendees can download a copy of this presentation and access playback of today's webinar at pumpsandsystems.com/webinars. Thanks for taking the time to join us today, and everybody have a great afternoon.
Thank you.